Let's take a look at an example of finding a derivative that incorporates the use of the power rule along with the chain rule and the quotient rule, as well as other rules. But those are the main focus of this video. So let's go ahead and get started. So the first thing to notice is that we have a function that is raised to a fifth power. So the argument of the function is this rational function inside the fifth power. So as we go to find the derivative here, we'll be using the power rule and then the chain rule. So we have a fifth power, so something to the fifth power is 5 times, leave that argument alone, to the fourth power, and then we'll multiply by the derivative of that argument. But I said we leave that argument alone, so let's go ahead and put our argument inside that fourth power. And then now we need to take the derivative of the argument. And so our argument is a rational function. We'll be using the quotient rule. So the derivative of the numerator is 2 times the denominator, 5x minus 1, minus, quotient rule always has a minus, the derivative of the denominator, 5, times the numerator, 2x plus 3, all over our denominator, 5x minus 1 squared. So at this point, we're going to go ahead and distribute within that quotient rule. So this 2 times the 5x and the minus 1, and this minus 5 times the 2x and the minus 5 times the 3. So we end up with our derivative f prime of x being 5 times 2x plus 3 over 5x minus 1 to the fourth power. Our numerator is 10x minus 2, negative 5, so minus 10x. Minus 15, all over 5x minus 1 squared. Okay, so our derivative now is, keep in mind your rules for exponents. When you have a fraction to a power, then you can raise the numerator to that power and then the denominator to that power. So by separating that fraction, this will allow us to combine the denominator on the left with the denominator on the right. So we will have 5 times 2x plus 3 to the fourth power over the quantity 5x minus 1 to the fourth power. And now where I applied the quotient rule here on the right, I've got a positive 10x and a negative 10x. So those sum to 0, leaving me with a negative 17 in my numerator and a quantity 5x minus 1 squared in my denominator. Now, we can go ahead and multiply the 5 and the negative 17. So 5 times negative 17 is negative 85 times the quantity 2x plus 3 to the fourth power. And in our denominator, we have the base 5x minus 1. On the left, raised to the fourth power, and on the right, raised to the second power. So when I combine them, we add exponents since those are being multiplied. And so when we add exponents, we get the 6th power. So 5x minus 1 to the 6th power. So this is our derivative of our original function. I hope this is helpful.